7.2 is more on sampling distributions, but this time we are going to talk about the sample proportions. So in the last video, we talked about sample mean and different types of sampling. So the goal is to anticipate the shape, center, and spread of a sampling distribution of sample proportions without doing a simulation. So in the context of the candy machine applet, here's the candy machine. This is of Reese's, Reese's Pieces. Explain the difference between the distribution of a population, distribution of a sample, and the sampling distribution of the sample proportion. So the distribution of the population. So that is the full machine of the candy. So all of the pieces of candy in there. One dot, which is just one piece of candy. So that's the entire population. So remember, sometimes it is not realistic to find the actual population parameters. So we would need to do a sample. So a sample is like what's down here. Let's say that these fell down after we twisted it and then we sorted it by color. So the bin below the machine where the candy falls out, that is going to be a sample. We're going to put that in our hand and we are going to count how many of each. And so each dot is one piece of candy from a sample from the whole population. So if we wanted to find the sampling distribution of the sample proportion, we'd do a dot plot. And we could do, this would be a dot plot, number of orange. So we would count up how many orange there are, and we would do the number of orange, or actually we'd probably want to do a proportion. We would find out what percent out of our sample is orange. So it'll be p hat. One dot is percent of orange from one sample. So let's describe what we know about the shape, center, and spread of a sampling distribution of a sample proportion. The shape. Shape is sometimes approximately, so that's going to be a symbol for approximately, normal, but depends on the sample size and the population proportion. We're going to use our large counts test, which we learned about last unit, to help us determine this, and you'll see that on the next slide. So approximately normal, but it also depends on the sample size and the population proportion. The center is going to be our mean. Mean of the dot plot is approximately the same as a population parameter. P hat is an unbiased estimator of P. So you find the mean of all the sample proportions. And that is an unbiased estimator for the population proportion. Our spread, for a specific value of P, the sigma of P hat gets smaller as n gets larger. So if we have bigger sample sizes, the spread or the standard deviation will decrease. Our variation will decrease with bigger sample sizes. But we still got to be careful because of this large counts rule. All right, so let's talk more about that large counts test. When is it okay to say that the distribution of P hat is approximately normal? So it is okay when it meets our large counts condition. If n times P is greater than or equal to 30, so n is how many samples we have, the proportion, and it's greater than 10. And then n is also times 1 minus P, which is our complement, greater than or equal to 10. So that's what we're going to look for. What are the mean and standard deviation of the sampling distribution of a sample proportion? Well, the mean of our sample proportions equals the population proportion, because that is an unbiased estimator. Are there conditions that need to be met for these formulas to work? Yes. Here is our standard deviation. Oh, here's our standard deviation. I'm not to that problem yet. The standard deviation is this formula right here. And these are on your formula chart. So the conditions that need to be met to use those proportions is just the 10% rule. So can only use if the 10% condition is met. N is less than or equal to 1/10 of N. N being the population. All right, so let's apply this to a problem. The superintendent of a large school district wants to know what proportion of middle school students in their district are planning to attend a four-year college or university. Suppose that 80% of all middle school students in her district are planning to attend a four-year college or university. What is the probability that a simple random sample of size 125 will give a sample proportion of at most 75%? So we're going to look at several things. Let's start with what is the proportion. Proportion of students, of all middle school students who are planning to attend four-year college is 80%. So 0.80 is our P. Superintendent said that this is a large school district, so we know that it has thousands of students. It says that we are doing a sample size of 125. Let's check and see if it's independent. Check the 10% condition. So remember, to say it's independent without fully knowing, we can do that 10% rule. So 125 times 10 less than some large school district. So that's like 1,250. A large school district is going to be over probably 10,000, 20,000 students. So this is safe to assume. A large school district is more than 1,250 students. So we're good on that. You just have to use the context. Okay, the center is going to be the mean of P hat equals P, which is 0.80. Because this is an unbiased estimator, so it should equal 0.80. And then we have the spread, which is our standard deviation. We plug in what we know. So P is 0.80, 1 minus P is 0.20, N is 125. We end up getting 0.036. The shape, large counts test, we need to do, we want to say that it's normal, but, or approximately normal. So let's see. N times P is less than or equal to 10. N times 1 minus P. So we'll plug this in. We get 100 is greater than 10. Good. 25 greater than 10. We're good on the large counts test. So we can say it's approximately normal. Sampling distribution of P hat is approximately normal. So then we would want to solve this by using our normal distribution with here's mean, here's standard deviation. We want to see at most 75%. So real quick, what if it doesn't pass the large counts test? We would have to do a simulation or binomial distribution to help us find the probability. But since we know that's approximately normal, we can use normal distribution. All right, so we would put it into their calculator, or we could do it into Desmos. P has less than or equal to 0.75. So we would do our, it says at most, so that means between 0 and 0.75, so less than or equal to 0.75. So our lower bound would be negative 10,000, upper bound would be the 0.75. We'd want to put this in the calculator, and we would end up getting 0.0824. So 8%. So what's the probability that the sample proportion would be at most 75%? It's only 8.24%. So not a very good probability. So it's going to be a lot greater than that. All right, so that is it for our notes.